Today's lecture, we're going to continue to solve for solutions of a polynomial. First topic that we're going to talk about is factor theorem. I mentioned it in the previous lecture. We're going to focus on it a bit more today. So what is a factor theorem? Let's assume f is a polynomial. Then if f of x divided by x minus c is another polynomial qx with zero remainder, then what we say is there is no remainder. So therefore, x minus c is a factor of f of x. So we say x minus c is a factor of f of x if there is no remainder. So if there is no remainder, you can write a polynomial as a product of x minus c with some other term, qx, some other polynomial. Okay, now if you calculate what is f of c, it would be c minus c would be 0 times q of c. Therefore, the result is 0. So if x minus c is a factor of f of x, then what you can say is f of c must be 0. And the reverse is true as well. If f of c is 0, that means by the remainder theorem, when you divide f of x by x minus c, what you get is no remainder. So therefore, x minus c must be a factor of f of x. You can think about it both ways. This is what the factor theorem is about. And how do we use factor theorem is through, maybe I'll show you through an example. For example, if they ask you, is x minus c a factor of f of x? So what does it mean? If it was a factor, in this case, if x minus 3, if it's a factor, then f of 3 must be 0. So you just need to figure out what is f of 3. You don't need to do the long division or synthetic division. You just need to figure out, is f of 3 equal to 0? If it is 0, then you can say, yes, x minus 3 is a factor. If it's not 0, then you can say, no, it's not a factor. So what do we do? Again, you can calculate either way by replacing 3 into the function, or you can go through the synthetic division. Either way is fine. You can go through either one. I'll show you both ways. If you replace 3 into the function, the coefficients are 1, negative 1, negative 11, positive 11, and 12. These are the coefficients of, in order, x to the 4, x to the 3rd, x to the 2, x to the 1, and this is the constant term. These are given, and 3 is the value that we want to calculate, f of 3, the constant c. This c in the factor theorem. Drag down the 1, multiply 1 by 3, you'll get 3, add 3 and negative 1, you'll get 2, multiply 3 by 2, you'll get 6, add 6 and negative 11, you'll get negative 5, multiply negative 5 and 3, you'll get positive 15, negative 15, negative 15, add them up with 11, you'll get negative 4, multiply by 3, negative 12, add them together 0. So this 0 at the end, this is what our remainder is. So I can say f of 3 is exactly 0 because the remainder is 0. So what does it tell me? It tells me if f of c was 0, therefore x minus c is a factor. Therefore I can say yes, x minus 3 is a factor. And if you want to write f of x as a factor form, you already have x minus 3 as one of the factor. The other factors, as we discussed last time, by the long division, you can get the factor through these coefficients, these constants. This is if the remainder is 0, there will be exactly the term that you multiply by x minus 3. This is the constant term. This is coefficient of x squared, coefficient of x cubed. So what do I say? I say 1x cubed plus 2x squared minus 5x minus 4. This is exactly the same as these two are exactly equal to each other. If you distribute x minus 3 into the other polynomial, you should get exactly f of x. So this factor theorem basically is useful to reduce the degree of the polynomial. Now, instead of having x to the power 4, you have a factor term and another polynomial which is you have a linear term and another polynomial which is a third degree polynomial. Okay, here's another example. This time, instead of having, let me shift this up a bit. Here we go. Okay, you're given a polynomial with a 0. They say if you replace -5 into the polynomial f of x, it's a 0. And they ask you to figure out what are the other zeros. So what does it mean? That means I know -5 is a 0, which means f of -5 equals to 0. That's what it means. And by the factor theorem, this means x minus -5 is a factor of f of x. F of x. So if x minus -5 is a factor of f of x, that means if you divide f of x by -5 through the synthetic division or through the long division, either way, you divide by -5, you'll have 3, 25, 42, -40. These are again coefficients in f. If you do this division, let's drag down the 3. 3, -15, you'll get 10. -50, you'll get 8. And if you multiply, that will give you positive 40. This is probably positive here. Oh, sorry, this is -8. There we go. Positive 40, and you'll get 0. Since they say f of -5 is 0, you should get the remainder of 0. Otherwise, x minus -5 is not a factor. So x minus -5 is a factor of f of x. What is the other factor? The other factor is coming through this constant value, coefficient of x, coefficient of x squared. So what is the polynomial f of x looks like? It's given 3x cubed plus 25x squared plus 42x minus 40. But we can factor it. One of the factors is x minus -5. The other factor is basically 3x squared plus 10x minus 8. From this division, you can find the other coefficients, the other polynomial. So how do we find the zeros? If you want to find the zeros, either you set this equal to 0, which is the same as saying this is equal to 0. So x minus -5 equal to 0, x minus -5 equal to 0, or 3x squared plus 10x minus 8 equal to 0. This one already gives us the solution x equal to -5. This is what we started with. It is given already. So we're just confirming that this is a solution. The other one is a quadratic equation. If you can factor it, factor it. If you cannot factor it, use quadratic formula. Either way is fine. Here, let's say you use quadratic formula. There's a factor, I think, possible for this one. I think it's 3x, x, let's think, minus 2 plus 4. Yeah, I think this is a factor. And if you factor it, you'll get x equals, so either this parentheses is 0 or the other one is 0. Therefore, you'll get x equal to 2/3 and x equal to -4. So what did I find is the other two solutions. There are 3 zeros. One is -5, the other two are 2/3 and -4. If you replace 2/3 and -4 into the polynomial, you should get 0 as well. So if you're given one of the zeros, it helps to figure out the other two, because you're reducing the degree of polynomial from being a third degree polynomial to a second degree polynomial just by dividing into the other linear term. Okay, these are some outcomes of the factor theorem. So if we knew the zeros, we would be able to figure out other zeros by reducing the degree of polynomial. So our main focus would be how to guess one of the zeros at least. This is why we're going to focus on this rational zero theorem. Rational zero theorem is used to figure out the integers or rational zeros of a polynomial. So rational zeros of a polynomial means its solution to the polynomial f at some fraction p over q equals to 0. That means p over q is a zero of f. We're looking for these specific solutions. If there is a solution in the form of a fraction, it could be 3 divided by 1, which is an integer. But if it has that format, can we figure out the which case is it? We don't want to go through all the numbers. Can we reduce it down and figure out those? So the rational zero theorem is basically says, if you have a polynomial of the form, this is just a notation, an x to the n, an minus 1 x to the n minus 1. That means we put the polynomial in descending order. An is the leading term coefficient. A0 at the end, this is the constant. This is the leading term coefficient. If we do that, and if this polynomial has a solution as a fraction, as a rational number, then that rational p over q should satisfy this property. P must be a factor of a0. What is a0? Is the constant. So p is a factor of that constant, of the constant. And how about q? Q is a factor of the leading term coefficient, This only gives you the possible. It's not like every number is going to be a 0. You may not get any 0 in terms of rational numbers. But if there is a rational solution, it should satisfy this property. And we use this to list the possible rational zeros. We go through those zeros, those rational numbers, to see if we find a 0 or not. So here's an example. This is a given polynomial with the integer coefficient and the leading term coefficient. This is the leading term coefficient. The constant term plus 10. And here the question is, list all those possible rational zeros. It doesn't mean they're going to be 0 for f of x. I mean, it is possible that one of these or maybe multiple of them are rational zero, or a 0 of f of x. If there is a fraction that is a 0 of f, it has to be one of these. Okay, so how do we find them? Again, leading term. I'm going to write it leading term coefficient. Normally we use an to show it. So an normally stands for the leading term coefficient. In this case, what is that leading term coefficient? It is -2. This is, for our fraction, this is the q. Q is correspond to the leading term coefficient, factors of an. Sorry, q will come from a factor of these -2. And we have the what is the other term? Is the constant, the other value that we care about. What was the constant? The constant was +10. The plus or minus doesn't really affect the factors, but it's important you consider it as well. So here, what I'm going to do is I'm going to focus on the factors of these numbers. What are their factors? Let me choose a different color. What is the factor of -2? It could be 1. It could be -1, 2, and -2. These are the only numbers that you can divide -2 by. And what are the factors of 10? 1, -1, 2, -2, 5, -5, and don't forget the 10 and -10. These are all the possible factors that 10 has. There's a shorter way of writing it, by the way. Instead of writing it this way, you can write it as plus or minus 1, plus or minus 2, and plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. These are all the possible factors of -2 and +10. So what do? We say if there is a solution P over Q, it should be P should come from these factors, and Q must come from, Q must come from the factors of A, N, and P should come from the factors of the constant. So here, P is the factors that comes from the constant, Q is from the factors of the leading term coefficient. So what are all those possibilities? I'm going to fix one. For example, you can fix Q. Q should be either plus or minus 1. Then the numerator could be plus minus 1, plus minus 2, plus minus 3, 5, plus minus 10. All divided by plus minus 1, plus minus 1, plus minus 1. This is one of the sets of factors. The other set is if the denominator was 2, then what you get is plus minus 2, plus minus 2, plus minus 2. And what would be the numerator? The numerator could be plus minus 1, plus minus 2, plus minus 5, and plus minus 10. If you go through all these fractions, what numbers do you get is, so these are all the possibilities, P over Q. 1 divided by 1, -1 divided by -1, 1 divided by -1, and -1 divided by 1. All these possibilities reduce down to 1. All this. If you go through all these possibilities, the result would be only two numbers, either 1 or -1. The same, if you go through all these, 2 divided by 1 would be 2. You'll have either 2 or plus or -2. The same here, you'll get plus or minus 5, plus or minus 10. These are all the possibilities so far if you divide by 1 or -1. On the other side, if you divide by 1 or -2, you'll get plus or minus 1/2. Either you get 1/2 or -1/2. You'll get, if you divide this one, you'll get either plus or minus 1. This last one, you'll get, this next one, you'll get plus or minus 5/2. And finally, at the end, you'll get plus or minus 5. Why do we simplify it? Why did I simplify it is because of this specific reason that you will see repeated numbers. You will see plus or minus 5, here plus or minus 5. So you don't really need both of them. You can ignore one of them and say, I will ignore this one. I will delete that. And same here, plus or minus 1. Again, plus or minus 1 here. So I don't really need to write plus or minus 1 twice. I've already counted for that. So at the end, what are all the possibilities? Plus or minus 1, plus or minus 2, plus or minus 2, plus or minus 5, positive and -10, positive and -1/2, positive and -5/2. These are all the possibilities. So if there is a rational 0 to this polynomial, one of these numbers should be that rational 0. Okay, here I'm going to show you, there are too many in this case to go through all of them. So in the next example, we're going to find the zeros of f of x by using this rational rational theorem. So what are the possibilities here? First, figure out the factors. The an is the coefficient of the larger term. In this case, the leading coefficient is 1, and constant c, or a0 is the very constant 2. This constant 2. And you want to figure out the zeros of this polynomial. If you set it equal to 0, You cannot really factor this. It's not easy to guess what are the factors. What you can do is you can figure out at least one of the solutions, then divide by using the factor theorem. Okay, so what are the possibilities of P? Sorry, P is here. What are the possibilities of Q? Q could be plus or minus 1, P could be plus or minus 1, and plus or minus 2. So what are all the possibilities of P divided by Q? It could be plus or minus 1 divided by plus or minus 1, or plus or minus 2 divided by plus or minus 1. These are all the possibilities. You can reduce it by simplifying them. You'll get plus or minus 1 and plus or minus 2. These are 4 numbers now, either positive none, negative 1, positive 2, or negative 2. So if f of x has a 0 in terms of rational numbers, it should be one of these 4. 1, negative 1, 2, or negative 2. Can we figure out which one is the 0? You could do that by either replacing the number into the f or use synthetic division. Either way is fine. I'm going to use synthetic division because if it's a factor, then I already have the factors of it. I'll start with 1 to see if 1 is a factor. If x minus 1 is a factor, or if 1 is a 0 of f. I'll divide f by it. 1, negative 4. These are the coefficients, 3 and 2. Drag down the 1. 1 times 1, 1. Negative 3, negative 3. 0, 1 times 0 is 0, 2. So here I can simply say 1 is not a 0, because at the end I got a remainder. So 1 is not a 0. How about if we try 2? You should try every number. 1, 2, negative 1, negative 2. I'm going to jump ahead from 1 to 2. 1, negative 4, 3, 2. So kind of, this 1 was useless to us. It didn't give us any information about a polynomial. It says it's not a 0. Okay, nothing else we can do. Okay, here, if we drag down the 1, again, 1 times 2, 2. 2 times 2. 1 times 2 is 2. 2 and 4, negative 2. Negative 2 times 2 is negative 4. Add them up, negative 1. Negative 2. Here we got 0. So what can I say? Remainder is 0. Therefore, 2 is the number that we were looking for. It may not be the only number, but in this case, if I know one of them, I can reduce the degree of polynomial from the 3rd degree to 2nd degree by dividing. So what are the zeros of f of x? F of x could be factored in terms of x minus 2 through this solution, x minus 2. What is the other factor? Through these numbers. If you remember, negative 1 is a constant, negative 2 is coefficient of x, and 1 is coefficient of x squared. So here we go. We factored f of x in terms of x minus 2 times 1x squared minus 2x minus 1. So now if I'm looking for the zeros, that means if I set it equal to 0, what can I say? I can say either this is 0, which gives me x equal to 2, or I can say this one is 0, x squared minus 2x minus 1 equal to 0. How do I find the solutions? This is a quadratic equation. I don't think you can factor it. Sorry. So you can use... Oh, you can factor it actually. No, it should have been positive 1 to be able to factor. Okay. I think it's too late and I'm getting tired. X squared minus 2x minus 1 equal to 0. You can use quadratic formula. X would be minus 2 plus or minus square root of b squared 4 minus 4ac, so plus 4 divided by 2. You can simplify it to 2 plus or minus square root of 8 is 2 root 2 divided by 2. You can cancel out the 2's, divide everything by 2. We'll get 1 plus or minus 1 root 2, which is just root 2. So I found the zeros of the polynomial. One of them was a rational number, 2, and through that one, I figured out the other two, 1 plus or minus square root of 2. Okay, so now this factor theorem plus the rational zero theorem are very useful to figure out most possible zeros first, and by doing the division, synthetic division, and using the factor theorem, you can figure out the other zeros, even the rational ones. Okay, I'm gonna stop here. This is it for this section.